Okay, great. Okay, so today I'm going to talk about the what I call the Great American Eclipse doubleheader. And we're going to have two eclipses, as you well know, a total and an annular, just 6 months apart in the United States. The annular is going to cross on October 14, 2023, in just a few months, and last 4 minutes, 29 seconds. And the total is going to be 6 months later, April 8th, 2024, lasting 3 minutes and 50 seconds. And the last total that occurred in the United States was August 21st, 2017. How many people saw that one? Show of hands. Oh, quite a few. Good. And the next total eclipse. So you better see this one on April 8th, 2024, because the next one will be 20 years later, August 23rd. And that one's going to be 2 minutes and 4 seconds. That's going to be around the Western United States. And I'm going to be 85. So I hope I make it for that one. And for these both annular and total, the entire US will experience a partial eclipse on both occasions. So don't miss this once in a lifetime experience. And then I gave this talk to some astronomy groups in Florida, and on August 12th, 2045, I'll be 86. There's going to be an eclipse that goes right through Florida. And one point I want to make with this slide is when you're seeing an annular or total eclipse, you want to be in what's called the center line here, right in the center. These are the paths. If you're outside here, you're not going to see the eclipse. If you're here, you're not going to see the eclipse. You need to be in the center line. And this is going to last 6 minutes. And that's pretty long because the theoretical maximum is about 7 minutes. And you can all see my cursor, right? And if you're in Tampa, you're only going to get like 4 minutes. So you lose 2 whole minutes. If you're in St. Petersburg, you get 3 minutes. So here you lose a whole 3 minutes. So you don't want to be near the edges. You want to be as close to the center line as possible. If you're here in Orlando, 550 isn't too bad. You're only losing 10 seconds. You're never going to be exactly in the center line. As close as you can get to it, that's what you want. Okay, so 3 types of solar eclipses. You have the annular, the total, and the hybrid. And there was a hybrid April 19th, 2023, a few months, last month or so. And that one, what happens during a hybrid is part of the path will be total and the other part will be annular. So if you were in Australia, you saw it total, and if you were in Indonesia, you saw it annular. So that's kind of neat. And now with today's technology, they have live streams. NASA has live streams of these solar eclipses. So I was actually watching it live here in from my home, and it was my time 11:30 to 1 a.m. So I stayed up the whole time and watched it. So it's still a thrill to watch it in real time. But if you can't, it's recorded and it's on YouTube. So for most locations, all right, in all cases, you must travel to see and experience the celestial phenomena. And it's not merely a vacation, it's an adventure. It's pre-planned by nature. You have to be in the center line. You can't be anywhere else in order to see this. So it's kind of pre-planned. You don't have much say. And it's a rare opportunity to witness, like I said, both an annular and a total 6 months apart in the continental US. So for a solar eclipse to occur, all of them, total, annular, and hybrid, it needs to be new moon, when the moon is between the earth and the sun. The sun is out here, okay, illuminating the moon. And during full moon, when the moon is over here, you'll see a total lunar eclipse, okay? So the moon and the sun have the same angular diameter in the sky, which is really neat. The sun is average 93 million miles away, and the moon is only 250,000 miles away. But in the sky, they subtend the same angular diameter, about half a degree. So that's kind of neat. But during an annular, the moon is slightly smaller than the sun, so it doesn't quite cover the whole sun. So you get a ring, okay, and so an annulus. And so you need eclipse glasses to see it the whole time, okay? And you need to order these now. You can get them from Amazon, and they used to be $1 a piece. Now I'm seeing them for $3 a piece. And if you buy several of them, they're cheaper. And I bought these for $20. These are nice plastic ones. So these are much, much nicer. So you have to wear these Eclipse shades the whole time. Okay, you know that. So purchase them now, because the closer it gets, you won't be able to get them. And if you can, the cost will be astronomical. Pardon the pun. Okay, so during an annual eclipse, the whole country will see a partial, which is really cool. And Rhode Island will see only 20%. Florida gets a better clip, 60%. And but you'll see a good 20%, which is good. So if you don't want to travel to the path of annularity, and fortunately, Rick Lynch, give Rick a hand. He really organized a great trip to Albuquerque, New Mexico, which is right on the center line. And so if you're on the fence, should I go and spend the money? Just do it. Don't even think about it. Do it, because it's nice to say that you saw both eclipses in the United States 6 months apart, the double header. And then here you'll see you get eclipse. This is all you'll see basically in Rhode Island. That's about 20%, see. But that's all you'll see. And then it gets more and more, and you see this beautiful ring, and then it comes back, okay? And then here's how it'll look. Basically, this is a little time lapse. This takes about maybe 5 minutes to 10 minutes or so to form this ring, and then dissipate. So totality. So that's basically it on the annular eclipse. Any questions? Okay, so we'll start with the total eclipse. The total eclipse, same thing during new moon, and the moon, and now the moon is slightly larger, so it's actually able to cover the whole sun, and you see that white, beautiful corona. And total solar eclipses were important because in May 29th, 1919, Sir Arthur Eddington verified Einstein's general theory of relativity, because it gets pretty dark during the total eclipse, and you're able to see stars and even planets near the sun, nearby. And so Eddington was able to verify how far the stars were displaced from their normal positions as predicted by relativity. So that was the first proof of Einstein's general theory of relativity. So question, why are lunar and solar eclipses not a monthly event? If, you know, the moon goes around the earth every month, when it's here, we should get a solar eclipse. When it's back here, we should get a total lunar eclipse. Why does it not happen every month? Does anyone know? Yes, how much? Do you remember?
I don't think he heard you, Francine.
Does it become
5 degrees.
What? 5 degrees, excellent. So the moon is inclined at an angle of 5 degrees. So it always misses this, okay? It's either above or below, okay? And here's a diagram. Here's the earth. The ecliptic is the sun's path right here. And where the sun and moon meet, that's called a node. I'll talk more about that later. But if you look at the plane of the moon's orbit, it's above that of the sun and the earth, see? It's above or below. So it usually misses it, okay? And that's a good thing, because if this happened every month, it wouldn't be a big deal. You know, you'd say every time there'd be a total, the moon would be full, it would be eclipsed, and you wouldn't think like it. So if it happened every month, I mean, full moon happens every month. No one's excited. Oh, I'm going to sit and watch a full moon for hours every month, right? No one cares. So the same thing would happen if the moon was eclipsed every month. So it's kind of a good thing that it misses it. So when it does actually happen, it's an exciting event. Okay. Now, a node is a point at, let me read this first and I'll explain it. So a node is a point in space where the sun's orbit, the ecliptic, crosses the moon's orbit. Each time the moon completes an orbit around the Earth, it crosses the Earth's orbit at a point west of the previous node. Each year, the nodes regress 19.4 degrees, making one complete revolution 18.61 years. So a solar eclipse will occur in the same part of the sky. Location of the Earth will be different. This is known as a Saros. So you've heard of the Saros cycle. So this is what it is. So here's the ecliptic. The ecliptic is the path of the sun. Here's the path of the moon. So where the path of the sun crosses that of the moon crosses the path of the sun is a node. So each time this happens every month, it occurs a few degrees west. It never occurs in the same spot. So this is a regression. They're always moving. So they move 19 degrees each year. So in a year, this node has moved here 19 degrees. And then 18.61 years to make one revolution takes 18.61 years for this node to come back here. And that's a Saros cycle. Does that make sense?
Mm-hmm. Yep.
And I remember I went with skyscrapers in 1991. There was a really long eclipse in Hawaii, and several of our long-term members here went with me, and we were talking about that earlier. And Brian McGaw was the team leader, and unfortunately he passed away in his mid-30s at a young age from lymphoma. He was a good friend. I really miss him, but he led the group, and we were at a lava field, and it felt like we were on the moon. And what was funny is someone ordered a pizza, so we saw Domino's pizza driving by and giving us all pizza on the moon, so it was kind of
at 2 o'clock in the morning.
Yeah, 2 o'clock. Oh, that's right. It was a very late eclipse. That's right. And unfortunately, it was clouded out too. So I remember only the end phases we saw. So I didn't see totality, but I saw it get dark, experience it. And it was almost 7 minutes. And the Saros of that was in 2009. And I went to, my wife and I went to Shanghai, China to see that. And it was raining out that day. So that was a long one too, because it was a Saros of that one. So that was almost 7 minutes. So I experienced 7 minutes of rain in the darkness during the eclipse shadow. And then the other one that I was snowed out in Mongolia in the 90s. So I went, and there I met the late Dr. J. Pasikoff. So but those were the three. The other 9 I saw. So that was good. But those are the 3 that I missed. So does this kind of make sense, the Saros cycle? Okay. All right. So New England is at a prime location for this eclipse, and it happens around 3:15 to 3:30, and that's a good time because you don't want early morning or eclipses, because as the sun is rising and the eclipse begins, there's a lot of clouds that form around the morning, around the horizon, and the sunsets around the horizon, because the air is, getting more turbulent as the temperature, and, it transitions from night into day or day into night. So you want it kind of higher up. So at 3:30 in the afternoon, it'll be pretty high up, and so it would have to be pretty overcast overhead in order for you to miss it. So that's kind of nice. But from what I've been told, April is not a great time in New England. It's rather cloudy. So Skyscrapers has set up a trip to Waco, Texas for it. So I would highly recommend taking that trip, because you want deserts, and Texas is a great desert state. And the likelihood of seeing it there is much greater. You don't want to miss these. And then here, Texas, like I said, here's the San Antonio will actually see both. The annular here and then the total here. So that's fascinating. And so now totality, here's the animation. You see this beautiful corona. And then first contact. So when the moon first begins to cover the limb of the sun, the first little bite, okay, that's called first contact, and you need eclipse glasses to view, all right, the whole time. And then during a period of 90 minutes, the moon obscures more and more of the sun, and the sun appears as a narrow crescent. You still need your eclipse glasses. Then about 15 minutes before totality, the sun is about 80% covered. Light level really decreases, okay? And you sense a perceptible temperature drop, and the landscape appears to be darkening. It's a really eerie, cool feeling. And then just before totality, 15 minutes, it starts getting dark in the horizon as the shadow starts approaching, just like a thunderstorm is approaching. And as the level of sunlight falls, you hear animals, birds start chirping, insects start chirping, you hear the crickets going crazy, the birds start chirping too, because they're becoming anxious. They don't understand what's going on. It's the middle of the day and all of a sudden it's getting really dark. So they're really confused. And also, notice how people around you are reacting. You know, people start getting all excited and everything. And then one other thing you'll see during the total eclipse are what are called shadow bands. And you can read this for yourself. They're just basically air currents that you're seeing. Now, I've been on several eclipses and people have yelled, shadow band, shadow band. And I looked down really quick. I can't say I really seen them. The real action is happening up there with the corona. See, this guy's photographing the shadow bands and this guy's photographing the eclipse. So you only have less than 4 minutes to see it, totality, the best part. So don't focus on the shadow bands, which are really secondary. But I think on the 2024 eclipse, that's a good idea. I'll take a white sheet and then put some rocks here and see if I can actually see shadow bands. And if I can, I'll take a quick iPhone photo of them. But, you know, I'm really focused on what's going on there. You don't have very much time during totality.
It's worth the effort. It's worth
what?
the effort to do. Look for shadow bands.
Have you seen those?
Dave Rose and I in the 80s drove down for the annular eclipse that had a totality of less than 3 seconds. We set up sheets on the ground. We couldn't figure out why we were so welcomed by the people in Georgia, but they found out we brought sheets. So I guess we set these sheets down, but we were constant, and all these people showed up and we didn't know what to do with them. So I explained what shadow bands were. I explained that's why the sheet was there. And as the moment of totality was about to occur, we heard this commotion. And Dave and I looked over at the people, and down on the sheets were these undulating shadows. If you could envision the bottom of a swimming pool on a sunny day with the water chopping and the undulation of light in the bottom of the pool, well, if you made that light into shadows, that's what the shadow activity was that we saw. And it was so fascinating, I almost missed the eclipse because of it. So you're justified in your concern.
Yeah. Was that a hybrid eclipse or?
They did not know if that was going to be a true annular eclipse or a broken annulus. And it ended up being a broken annulus, which was spectacular, but we didn't see the corona.
All right, yeah. All right, great. So with both both the total and annular eclipse, you get these what are called Bailey's beads, these blobs here, and those are rays of sunlight passing through deep valleys in the moon's limb. They're very beautiful, the Bailey's beads. And then when you see the last bead is visible, it's called a diamond ring. And this is a photo I took. This is from a video still, actually. And when the moon covers all but one of Bailey's beads, then this is known as second contact. Okay, this is actually a photo of third contact as it came out, but it's symmetric. It'll be here. Okay, and the thing is, don't look directly at the diamond ring. It'll hurt your eyes with personal experience. The last one I went to was in Chile just before COVID hit, and oh my God, it was. You can see the brightening. I could see this getting brighter and brighter. And all of a sudden, the diamond ring came out and it really hurt my eyes. And for like 20 minutes, I saw nothing but black in the middle of my eye. I couldn't see in the middle. Oh my God, scared the heck out of me. But it came back rather quickly. So I was really happy about that, but there was no permanent damage. But this will really hurt you. It's like a laser coming at you. And it happens fraction of a second, very, very quick. So now I'm a little wiser. When I see it getting really bright like this, I'm not going to stare at it very much. I'll look at my camcorder. It'll be safer, but be very careful on the ring. What?
Greg, how many carats is that?
How many what?
Ignore him.
Okay.
No, I just had to ask.
All right, so second contact. So during second contact, the big thing you see is the sun's outer atmosphere, which is called the photosphere, and this is the red. No, it's called the, oh, I'm sorry. The outer part is the chromosphere, which is red. The photosphere is covered, so you see the chromosphere. And this is the thin red layer of glowing gas, and it's red because of glowing hydrogen. And you can see the prominences. And if you look here, here you can see a prominence right there. And this was really the only time amateur astronomers could ever see prominences was during a total solar eclipse. But now, with hydrogen alpha telescopes, how many people own an H alpha scope? Oh, not that many. Oh, you got to get one. I know they're pricey, they're $2,000 to $3,000, but they're well worth it because, I mean, you're only looking at one wavelength of light, 656.3 nanometers, plus or minus like 0.05 if you double stack it. I mean, it's incredible. Filters out all other wavelengths of light. So, but now we can see it with a Coronado Lanter Daystar H alpha. Does the club have a dedicated H alpha scope for everybody?
No, we do not.
Oh,
It's
you
on my
don't?
list. It's on my list of things.
Oh, okay, yeah, okay, it's on your list. Okay, so the white corona is only visible during totality. And this is how it looks. And it is absolutely spectacular. So you can see a prominence here. And notice you can see, this is like a bar magnet here. These are the poles right here. And then this is the magnetic field lines. It's really beautiful. And this looks like an aurora. These are constantly changing and undulating, and it's just absolutely beautiful. And if you try to take a picture like this, you're not going to, because what happens is this is so dim. If you look at my shot here, notice this is overexposed. Usually the inner corona is overexposed in order to get the outer corona. You would have to take two types of photographs. You'd have to take this with the inner corona overexposed and the outer corona, and then you'd have to take the where you can't see the outer corona and only the inner corona. Then you have to combine them in Photoshop or PixInsight or GIMP and do a lot of digital magic to get a lot of this. I think Fred Espinek's, this is Fred Espinek's photo, but this is how it looks naked eye. And you can use binoculars to look at this, really enhances the view, but be very careful of the diamond ring coming through. Okay, so, and then you can see the prominences here. Can you trace the magnetic field lines? And mentioned a lot of this already. And look for any stars and planets nearby. Okay, so third contact, the western edge begins to brighten, and then the photosphere returns your diamond ring. Once you see the diamond ring again, the eclipse is over. That's third contact. And then you need eclipse shades right away because you can't look at it naked eye anymore. And now the stages of the eclipse repeat themselves in reverse order. Okay, and this is the one thing that absolutely amazes me and floors me, and is as the eclipse is coming in, everyone's getting excited. You know, it's 20%, 50%, 90%, right? Everyone's getting all excited. During totality, everyone's screaming and yelling it. And then after totality's over, everyone's hugging each other and breaking out champagne and wine, lighting cigars. No one's looking up anymore. And there's still 90% eclipse, 80% eclipse, and no one cares. Did you experience that, Scott and Rick? Did you guys lose interest after totality? What was your experience on
You
that?
do lose a little bit of interest.
Yeah, yeah, especially when it starts getting like 80% is on like 20% eclipse. But I see it as the whole process from very beginning to very end. Yes, the totality is the ultimate, it's the climax, but it's the whole process that's the whole 3 hour, process. So I'm usually right till the very end. And I spoke with Dr. Fred Espinek about it, who's Mr. Eclipse. That's his website, MrEclipse.com. And he said, I know what you mean, Greg. He says, NASA's paying me to be here and video and record the eclipse and photograph it. So I have to do it from beginning to end. But he goes, I know what you mean. And if you go on eclipse tours to other countries, a lot of times, once it's over 50%, coming back, everyone starts packing in the bus and leaving. And I don't want to go. I wait till the very end. At that point, no one cares, but I still do, I want to videotape it. So, but either way, point here is don't lose interest. Wait till the very end. Keep taking photographs, keep looking up. It's okay to have something to eat and drink and be merry and have a grand old time, but keep looking up because it's still happening. It's not over yet. It's not over till fourth contact, where the moon no longer covers the sun and the sun appears it would be any normal day and the eclipse is over. Okay, so the shape of the corona, as you know, there's an 11-year sunspot cycle, maximum and minimum. And during the 2017 eclipse, it was actually at solar minimum. So there were very few sunspots visible. The sun's disk was basically bland. And actually, I bought my Coronado Solamax 2 hydrogen alpha scope then because it was on sale. No one was buying H alpha scopes because there was nothing to see. The sun was bland because it was solar minimum. Now that it's solar maximum, the prices have gone up because there's a lot more to see. So during totality, during solar minimum, you'll see the corona more toward the equator here. Okay, whereas it's a lot more chaotic and a lot more symmetric and a lot more beautiful during solar maximum. And now we're at solar maximum. The sun's getting more and more maximum. So next year it'll be even more intense. So and then here you can see the prominences here on the sides. It's very beautiful. All right. So and then what's amazing now is the only time we could see a solar eclipse, I mean, the corona, was during a solar eclipse. And now there's an app for that. On your iPhone, you can get an app that shows the solar corona in real time. Here's what it is right now. Isn't that amazing? See, notice there's a lot going on. And then you can also see it wider. So it's amazing. There's a spacecraft, SOHO, Solar Heliospheric Observatory spacecraft, and it has this LASCO instrument, and it puts a disk on the sun, and you're able to actually see and measure the solar corona and in terms of solar radii and how many miles or kilometers they are, or arc seconds in diameter. So solar science physicists, love this because they keep an eye on the corona. So now you don't need a solar eclipse to see the prominences. You don't need a solar eclipse to see the corona. With modern technology, we can monitor it 24/7, which is really cool. And then, so why study the corona? First, learn how the sun works. What's interesting, this corona is actually hotter than the surface of the sun. It's 2 million degrees Celsius hotter, and no one knows why. Best theory is coronal heating via magnetic fields. So that's a big question for scientists here. And you can see the poles again here. See, here's the poles, and here's the magnetic field lines. So you want to study the corona because coronal mass ejections occur all the time with huge amounts of mass from the sun is ejected, plasma, and this interferes with shortwave and communications. And also can affect climate on Earth, and that affects the auroras too. And then also by studying the sun, which is a G-type star, you can learn more about stars. Use that as a model, since stars are just pinpoints of light in telescopes. So other than spectra, it's the only way to study them. And the sun is the best vacuum there is. And then plasma is just ionized gas. When hydrogen, the electron from hydrogen is ionized, then you just have H plus. Electric fields permeate and control the plasma and the direction of it. And then one thing I want to do this year is in 2024 is take a flash spectra. I purchased a diffraction grating, and I'm putting it in front of my HD camcorder, and I'm experimenting now, and I'm getting nice spectra from just bright lights and stuff. So I want to try a flash spectrum this time. I've never done that before. Okay, so tips for observing the Great American Eclipse doubleheader. So this has come from my experience since 1991 of observing eclipses. So first thing you want to do is know your dates, okay? October 14, 2023, it takes place on a Saturday, while the total eclipse on April 8th is on a Monday. So make sure you take sufficient time off of work, okay? If you're retired, that's not an issue, but many of us are still working, and so you need to at least take a week off. If you're just gonna go to Maine or New Hampshire or Vermont to see it, you just need that day off, basically, But if you're gonna go to Waco, Texas, which actually the preferred route, it's best to take a good week off. This you don't have to do because Rick Lynch has done it for us. Travel to the nearest city near the center line where totality will occur and find your observing spot, and then take GPS coordinates so that you know. When I went to my first eclipse was in '94. There was an annular eclipse in Texas, in El Paso, and so we went, and I set up in a church parking lot, and I got there like 4 a.m. because it was a morning eclipse. So I had the North Star, and I had a 8-inch Schmidt Cassegrain, and I videotaped it, prime focus through the eyepiece. And a police officer showed up, and he asked what I was doing, and so I explained it, and he asked if I got permission from the church, or did I contact the police station, tell them I was going to be there? And I said no. And I guess I don't look like a threat to society. So he let me stay. And I gave him some eclipse glasses, and he stayed and observed it with me. So he let me stay. And I said, oh, I'm only going to be here a couple more hours, then that's it. And I came from Florida and everything. So he was cool. But Rick, did you get permission for where you're going to be in Albuquerque and Waco? Did you have to get any special permissions?
Yeah, we're gonna be at a national park, Petroglyph National Monument, and NASA is gonna have a team there too, so.
Oh, okay.
What's
All
that?
right. So national parks, you wouldn't need any permissions, special permissions. You're right. But see, I was on private property, so it was different. All right. So you're all set. Good. So like I said, eclipse glasses must be worn the entire time. So basically here the whole time, eclipse glasses, this is the only time you can see it visually or with binoculars. And then you need eclipse glasses again. And this is what amazed me. Look at this. The eclipse is like 95+% still eclipse, and people lose interest. They're eating, they're drinking, they're hugging each other. They don't care anymore. I mean, keep watching it. Look, there's so much more to see. This still looks good. This still looks, even this looks, you want to see it till the very end. And this is basically what you're going to see in Rhode Island, about 20% for the annular. So please go to the Albuquerque. You won't regret it. Plus, it's cool to say that you saw the eclipse doubleheader. You saw both the annular and the total in the United States. That's a once-in-a-lifetime event. That should be on your bucket list. Okay, and then if you stay at home, which I hope you don't do, there's a great website, timeanddate.com, and there's a caption their eclipses, and it gives specific times for your location. And then now, like I mentioned, you can watch live broadcasts of totality on your computer or smartphone. It's amazing. And you can, another safe way to look at it is you can go like this with your fingers, like shown here, and it makes little pinhole cameras during the partial phases, okay? And then eyepiece projection is really good. Somebody can have a cheap refractor like this and just project it here. So this is really good for large crowds because not everybody can look through the scope at the same time, and then people can look at it here. And this is very, very safe. Or you can make the solar funnel, which is another variation of this. Are you going to have some eyepiece projection, you think, at Albuquerque or at Waco, Rick?
I'm not sure what everybody's bringing at this point.
Yeah, they probably won't, because most people want to look at it directly, you know, and photograph it too. But if somebody could bring this, this would be good for the general public. And if you're staying, you know, skyscrapers, you can have a public night of skyscrapers and have this so they can see 20% for the annual. Now, if you stay for the total, you're going to see like 90%, you know. So if you're seeing 90, it's foolish not to just drive a few hours and be in the path of totality and just take your chances with the weather in New Hampshire, Maine, and Vermont, you know. Okay, and then one thing about these glasses too is make sure when you purchase them, they have here what's called an ISO number, okay? And the reason the ISO is important is because the cheaper glasses will let through ultraviolet and infrared radiation from the sun that your eye can't see, and they can damage your retina and your eyeball. So make sure you get the higher quality ones, okay? So look that they have an ISO number. Then major manufacturers, Rainbow Symphony, Thousand Oaks Optical, Lante, Star, and Beta Planetarium. These that I bought the Rainbow Symphony, these nice ones here, and these are ISO, they even say it on it, so. And then, let's see, I mentioned all this too. And like I said, consider outreach, volunteering in the museum, library, or other facility, skyscrapers, Brown University, Roger Williams Park, etc. So, and then tips for observing the Great American Eclipse doubleheader. One thing you want to do is, if this is your first time, and most people here are seasoned astronomers, so this won't apply to you. If it's your very first solar eclipse, don't bother with photographing. Just enjoy the experience. You only have 3 minutes and 50 seconds of totality. That's it. So just enjoy it, okay? But and the other thing is you'll require expensive equipment and large focal length lenses that are very expensive. And like I said, during annularity or totality, you only have about 4 minutes for both. But if you want to photograph the partial phases, because it takes 90 minutes to go in and 90 minutes to go out. So you have plenty of time to photograph the partial phases, okay? But you only have 4 minutes on average for both eclipses. So you don't want to, you know, be fiddling with equipment. But, you know, if you have to, and then look at the size too. A 200 millimeter lens only gives you this size on, you know, what's equivalent to film. So you want at least a 500 millimeter to 1,000 millimeter lens, which is super expensive. This is a 4-inch telescope. That would be an 8-inch telescope. And you don't want an 8-inch because you're going to lose the outer streamers of the corona. So you do want it a little smaller with totality. And and there's this program, does anyone have any experience with this called Eclipse Orchestrator that automates your DSLR to take pictures? Anyone have any experience with this program? No, okay. So I can't say what to do with DSLR cameras. iPhones, it's going to be too small a photo, which I'll show later. But what I do is I take video. So I have this beautiful Sony camcorder, 4K camcorder, and then I have this telephoto lens, and this is Thousand Oaks optical solar filter, and this just pops on and off. So I keep this during the partial phases, and I keep this open, and I have this is a Star Adventure equatorial mount. So, and then this is a ball-headed carbon fiber tripod. So what I do is I just take my iPhone, and there's a leveler here, and I go to the to about what your latitude is. Your GPS will tell you, and point north, and then you're set to go. It's very forgiving because there's a lot of leeway here, and then you can always just move it back and forth here in the screen. And then one thing you want to do is change the battery just prior to totality. What I do is I videotape the entire eclipse from beginning to end. So I start a few minutes before theoretical time of first contact, and I'll do 5-minute videos, and then I'll stop. And then I'll wait 10 seconds and start again, take another 5-minute video, stop, wait a few seconds, start again. If you take one 90-minute video, it's going to be many gigabytes, and it may be a corrupt, and if the file's corrupted and won't play back, you lost all the partial phases. Here, you only lose 5 minutes if one of those files becomes corrupt, because you end up getting like 20, at least 20 5-minute intervals. So it's really nice, to do it that way. And so just before, like about 15 minutes before, I change the battery, because this does chew up a lot of battery power, especially with the screen. So, and even if you're using a DSLR, have an extra battery, switch it out, because you don't want during totality, everyone's, screaming and yelling and excited, the thing starts flashing red, low battery, it's gonna die on you, right? So, and definitely do that. And I learned that the hard way. It wasn't during totality with it, but it was about like 5 minutes before totality started flashing that my battery was gonna die. So I quickly did it. So now I do it a lot sooner. So make sure you do that. It's very important. So photograph the surrounding area. Do not use flash, especially if you use an iPhone. A lot of times the flash goes off automatically because of it's dark out. So make sure you don't use flash, and consider video, because you're able to relive the experience all over again. And now with GoPros and things, video's gotten a lot cheaper than it was in the 90s. Okay. And what's cool is when you travel with a group, afterwards everybody has a celebratory dinner, and when everybody's eating, people are showing their fantastic photos. And I was the only one that had a video. And when people saw the video, they started screaming and yelling again. They were like reliving the whole experience. And people were telling me, "That's a great idea, Grant. Next time I'm going to take video." Fred Espenick was the only other one taking video because he had to for NASA, for his job. But, video is great to take because it's nice to relive the experience. And you're not going to get as perfect corona as that, but you do see it changing, and you hear everybody screaming and yelling, and you hear the insects chirping and birds. And I mean, so you have sound too, which is kind of nice. A still photo, you don't have any sound. So it's very static. The video just brings it alive, which is really cool. And I have all of my video totality videos and annularity videos on YouTube. Just type Greg Shanos solar eclipse videos, and they'll all pop up and you can see them. And then here's how it'll look if you take a shot with an iPhone. See, it looks very, very small. See, so you do need aperture, but it's kind of nice. You see the surrounding area. See, notice the clouds. See, this is probably a sunset, sunrise or sunset eclipse. See how low it is? And the clouds are there. I'll bet if it were further up, okay, it would be a lot clearer. See, it's a lot clearer up here. And then here's another picture with some buildings. Okay, so like I said, so this is what I learned from my eclipse chasing. Use an umbrella to shadow yourself from direct sunlight. You don't think to bring an umbrella because you're sitting in direct sunlight. You get really heated up. So you really need an umbrella. Okay. Bring a beach towel and lawn chairs to sit on, because a lot of times you're in deserts, it's very dusty. So you don't want dust getting all over your equipment and on your person. Keep hydrated. Plenty of water, wear sunscreen. This is important. Bathroom break before totality. You don't want to say, oh my God, I gotta go, and you miss totality, all right? So, and this is more serious, like when you travel overseas and traveler's diarrhea can be an issue. So, but here we're in the United States. Well, it's true, you know. So, bathroom break before totality, you got to do it. All right. So I will, even if I don't have to go, I will run to the porta potty 20 minutes before and, and go. So clouds will obscure the view. So be prepared to move to clearer skies if necessary. Hey, do you have a contingency plan, Rick, if, the site is kind of, getting clouded, to jump in a bus and maybe go, 50 miles one
Not
way?
yet.
Not yet. Okay, kind of have that because the last one I went to 2017 was Nebraska, and Casper, Wyoming was the preferred place. And but we were in Nebraska, and we were at a nice hotel and that was on the center line, but the weather said that it was going to get cloudy. So we were with a group, so we jumped on a bus, and some people stayed at the hotel, and we went like 100 miles out in the middle of nowhere, and it cleared up there. And then we found out that people that stayed at the hotel saw it, it cleared up there too. We ended up going for the, but you don't want to risk it. You travel all that distance, you really listen to the weather, what they're gonna say. So try to have a contingency plan in case it gets cloudy. And don't fixate on the sky. Air temperature changes. Listen, like I said, insect, bird sounds. View the darkening along the horizon, take in the experience. And one thing that's fun to do, and now they have data loggers for this, but now I use a data log, but I was doing this manually, is take temperature readings every 5 minutes. And so since I'm videotaping, I don't write them down. I just say, 1:40 p.m. temperature, 85 degrees Fahrenheit, humidity, whatever, 52%, and then it goes down. And notice this was in Africa, June 21, 2001, which is actually the beginning of winter in Africa, okay? Because when the below the equator, notice, started 86 and went all the way down to 50 degrees during totality. Can you imagine? You're in shorts and a t-shirt, and then you need a coat because you're freezing. And then it came back to 70 by the time it was totally. This one I was able to see from very beginning to very end, which is nice. So look at that. So it's kind of neat to do a temperature and humidity, take measurements like that. Now they have data loggers, which I bought, that will do it automatically, which is nice. So, but I like doing it manually too. And then that's it. So total eclipse is one of the ultimate experiences of all time. Don't miss it. And we have an eclipse doubleheader, annular and a total in the United States, in our own country, 6 months apart. I mean, you got to see both. Don't just focus on total. You got to see both. So thank you. And
Thank you, Greg.
Thank you. Greg.
Appreciate it.
oh, you're welcome.